In this lesson, we're going to be talking about how to solve equations that have fractions in them. Now, there's going to be two methods that we're going to be going over. This video is what we'll just call Method 1, and you can go ahead and watch Method 2 to see how we deal with the same problems in a different way. But here's Method 1 of solving equations with fractions. Now, the first thing we're going to go over is some basic vocabulary. Inverse operations. It's key to solving any algebraic equation. That's operations that undo each other when solving equations. And as I've talked about in a prior video, addition, its opposite is subtraction, and it goes back the other way as well. Subtraction, the opposite is addition. Multiplication, the opposite is division, and the opposite of division is multiplication. Whatever you see happening, you just do the opposite one, or the inverse of that operation, in order to get rid of it, because that's how we're going to solve any algebraic equation. Now, in the situation here, though, unlike some of our other ones, we have fractions. Now, this Method 1, you can actually treat fractions just like you would any other number, any integer that you may have handled in the past. It's just that it's a fraction. In this first example, you can see that we have x plus 1/9 equals 7/9. I'm going to go ahead and put in my balance line, remembering that whatever I do on the left-hand side of that line, I have to do the exact same thing on the right-hand side. And I can see we're adding 1/9. So what we're going to do is, from both sides of the equation, subtract 1/9. Fortunately, the denominators are the same. So when we do 7/9 minus 1/9, you're left with 6/9. And of course, the last thing we need to do when you have fractions is you need to make sure that it is reduced. We see the number 6/9, and you can recognize that the numbers 6 and 9 are both divisible by 3. 6 divided by 3 is 2, and 9 divided by 3 is 3. Our final answer is that x equals 2/3. And then the last thing that we're going to want to do is to check our answer, as we always do for any algebraic equation. So we're saying that 2/3 plus 1/9 equals 7/9. Now I'm going to cheat a little bit here, but as we talked before about adding fractions together, they need to have the same denominator. We already did the work right here to show that 2/3 is the same as 6/9. So I'm just going to go ahead and change that right here. 6/9 plus 1/9 is supposed to be 7/9, and 6 plus 1 is 7. So absolutely, it's 7/9. It checks out. And if you remember, what I like to do from the previous video is to go ahead and box that final answer. Make it easier to track on your page. But that's our first problem that involves fractions. Now for this next one, we don't have the benefit of the fractions already being like terms. But we're still going to treat it the same way. We have a positive 3/5 plus x equal to a negative 1/2. I'm going to go ahead and put in my balance line. And everything I do on the left side, I have to do on the right side. We have a positive 3/5 that's being added to x. So we're going to combine that with a minus or negative 3/5. But these fractions don't have the same denominator, so we're going to have to do some work. We're going to go back to what we talked about before, adding fractions together. If you remember this little picture that I would often draw, to go along with that, we're going to do that same thing. We're doing negative 1/2 minus 3/5. Step 1, multiply across the bottom or the denominator. 2 times 5 is 10. and then we multiply at an angle in both of those cases. 5 times negative 1 is negative 5. 2 times negative 3 is negative 6. And negative 5 and negative 6 is negative 11. Took a little bit of work because of those unlike denominators, but I think it's pretty safe to say that x equals negative 11 tenths. Of course, as always, we want to check to make sure that that is correct. 3/5 plus negative 11 tenths. Now, from talking about adding and subtracting with fractions and integers, we can go ahead and change what we have written here. Instead of saying plus negative 11 tenths, we can talk about just subtracting 11 tenths. If you want to see a bit more of an explanation on why we did that, I'll recommend checking out that video. But we need to have a common denominator here. We're going to use this same trick that I used up here. 5 times 10 is 50. 3 times 10 is 30. And 5 times 11 is 55. 30 minus 55 is a negative 25. The denominator is 50. And 25 is half of 50. So we are getting a negative 1/2, which is exactly what we wanted it to be. So it is very safe to go ahead and box this final answer. We got it right. So let's go ahead and do another one. Here we don't see any plus or minus here because the operation is different. This time we're multiplying. And when we learned about multiplying and dividing fractions, you may remember the phrase multiply by the reciprocal, or the catchy way of saying it, keep, change, flip. Where all we're going to do is flip the fraction that's being divided out and just treat it as multiplication. The fraction that we want to get rid of here is 4/5. We're multiplying by 4/5 right now. So instead we're going to divide by 4/5, or by the multiply by the reciprocal or keep, change, flip rule. We're going to multiply both sides of the equation by 5/4. And of course these two fractions are essentially the same, leaving us with x equals. And then when we multiply on this side, well, let's see, 2 does go into 4 2 times. 3 times 2 is 6, and 5 times 1 is 5. I believe the answer is 5/6, but I'm not confident in that until we check it. We believe that 4/5 times 5/6 is going to give us the answer. Well, when you multiply these together, the 5's cancel. The number 2 goes into 4 2 times and goes into the number 6 3 times, giving us 2/3. And that's exactly what we wanted to see. So we got it right. X equals 5/6. And finally, we're just going to deal with one more that doesn't look like we have only fractions. We have the number 5, doesn't look like a fraction, and we have the number 6/7, that's definitely a fraction. We're going to treat this a lot like the problem that we just did, but you want to remember that when you see the number 5, that's really 5/1. Now it looks like a fraction, and we can do the exact same thing that we did in the prior example. I'll go ahead and do what I neglected to do last time and put that balance line in. I think you probably noticed you don't always have to do that, but it's a nice tool to have from time to time. And I'm going to multiply by the reciprocal, which in this case is going to be 1/5. And if I did it on this side, I have to do the same thing on this side. The 5's cancel. We have x equals. There's nothing to cancel over here. 6 times 1 is 6. 7 times 5 is 35. I believe the answer here is 6/35. Only way to know for sure is to check it. 5 times 6/35. Remember, this 5 is really a 5/1, so the 5 is in the numerator, and 5 goes into 35 7 times, giving us 6/7. That's exactly what we wanted to have, so this is the correct answer. And that's how to solve equations that involve fractions using the first method. I encourage you to check out the next video where we're going to do these exact same problems a different way.